Good afternoon, everyone. Thank you for coming to Power of Java Workloads on Google Cloud Platform session. Sorry for the half an hour delay compared to the original time, but thank you for being here. I think you're going to enjoy it a lot. So let's just start off with introductions. My name is Amir Rouzrokh. I am a product manager in Google Cloud Platform, responsible for Java and Python developer experience. And this is Patrick.
Hi, everybody. I'm Patrick Flynn. I'm the tech lead of the Java Tools team on GCP.
Great. Okay, so we have a lot of demos today for you guys, so I'm going to go through this a little bit faster so we make sure we get you guys all the demos that we're hoping for you to see. So let me just quickly talk about what we're going to touch on today. We are going to use the IntellIJ IDE. And just for me to understand sort of the breakdown, how many of you guys use IntellIJ to work with Java? Okay, wow. All right, it's pretty large. And how many Eclipse users? Okay, so I would say about like a 70, 30-ish. Okay, all right. And I know there's other IDEs and also other word editors, but okay, that's good to know. We're going to use a Spring Boot application, Java 8 based. That's what we're going to deploy. We are going to touch on two of our platforms, and I'm going to talk about our entire platform offering, but the ones that we're going to talk about today, or we're going to show demos on, is going to be App Engine Flexible Environment and Container Engine, which runs on Kubernetes. It's based on Kubernetes, it's probably more accurate. We're going to look at two of our services, Logging and Cloud Debugger. And we're going to do some infrastructure demos around A/B testing, load balancing, and auto-scaling. And I think it's going to be pretty interesting stuff that you're going to see. So, but before we go there, I'm just going to talk about some of the pain points that I think all of us deal with on a pretty daily basis. And we went and talked with a lot of our customers a couple of years ago and started really understanding what are the daily issues that they deal with. And the common thread was obviously like great developers and engineers that they had, but a lot of their time was being spent on non-core business workloads, doing things that are just not core to the business that they run. You know, first thing is, a lot of developers are pretty comfortable when they're in their IDE and they know their code is right over there and everything that they handle. But then when they need to do something with infrastructure, they have to leave that environment and start working with some web UI or some CLI or something like that. The A/B testing and traffic splitting was a big problem. People, get a version up and ready, and they want to put it out there to see if it's actually enhancing the product, if it's not breaking. Maybe they want to do some tests before rolling it fully out into production, and they needed to get networking involved for that. And that was a lot of hassle. Let's say that's all set up. Now they want to make sure that the scaling of this infrastructure is taken care of, and it's load balanced across all the instances. A lot of work there. Maybe spikes in the morning when people wake up, and then later when they go home, things just fall down, and they wanted to not have to worry about that. Security, another issue. Patches come out every once in a while. There's a vulnerability somewhere. They have to go back, patch that running sort of, application in production. That was tedious. Then there's always logs, of course. You have to figure out where you write them. Are you going to rotate these logs? And that's all sort of non-core to the business. And what we heard a lot about, and we're going to talk about this more today, is a lot of the developers just, would be bugs that appear in production, and then they wanted to get this bug to happen in QA or nightly or test or on their local machine, and they just couldn't replicate that bug that was live on their local machine to debug this. I'm curious, have you guys bumped into this before, where you had, if people are laughing, but if you could raise your hands, just want to know, okay, all right. So there we go. So yeah, so that happens quite often, and it's a big waste of time. And last but not least, people want to have this vendor flexibility. So if they decided to go with a cloud provider or a platform, they want to be able to, if they want to change their mind later, they don't want to have to go back and redo the whole thing. They want to just be able to switch between the layers. So we're going to talk about that and show that in the demo today as well. So we saw these pain points, and we decided, okay, it's good to put a product together that really talks to all of these. And today we're going to talk about App Engine Flexible Environment as the first part of our demo. And what is App Engine Flexible Environment? It is a fully managed application platform that basically allows developers to build web apps and API services. Okay, this is a really long description. Really what we're saying, you just bring your code and we'll handle the rest. You just focus on your business-specific code and forget about all the other stuff, pain points that we showed. And in the demo today, what we're going to look at is I'm going to try to do a description of what our compute offering looks like. So if you look at the bottom, that's Google's infrastructure. That's opaque to you guys. But the first layer is the virtual machines, right? Super high control. You get your VMs, and you can really do whatever you want with them. So that's GCE. Nice logo over there. And then if you think about what's the next level, that's containers, right? And if you want to have Kubernetes and container management on top of that, it gives you a bit more control over where the workloads are managed. You know, you're not just working with these pure VMs. We have a lot of flexibility. Still, there is work to be done in setting things up. Then on top of that, we kind of enter the serverless space where you're just not really thinking about the infrastructure at all. App Engine being the sort of like more flexible version of it, both standard and flexible, and we'll talk about that. And then Cloud Functions, which are also sessions about that if you guys want to join. But what we're going to really think about here is this space over here. We're going to start from the top, and then we're going to move down. That kind of shows you how you can go between the layers when you're working with your application. So, all right, what does App Engine give you out of the box? A lot of things. I'm just going to highlight 6 of them here. Logging comes out of the box. You don't need to worry about. We'll demo that. Auto-scaling and load balancing, pre-configured for you. Monitoring is there, so if things break and you want to be notified. Health checks, something is not working. An instance has gone unhealthy for some reason, and it's not working. You want to be notified. And then SSL and domains. So just to make sure we're on time, let me just talk about some of the environments, some of the languages that it supports. We're going to work on Java today, but if you have any one of the other languages here, you can deploy to that environment as well. Node.js, Ruby, Java, Go, Python, .NET, PHP, you got them all. As a matter of fact, you can use any Docker container as well, and that's sort of what's happening at the layer behind it. That's what's happening behind the scenes. So you don't, and we'll show you that to you guys, but you can go any other language as well, but these are pre-configured for you, and we found that this covers most of the languages that people use. So today's demo, we're going to use Google provided runtimes. They get security patched on a weekly basis, so you don't need to worry about that. On App Engine Flexible, you don't need any configuration files. You guys have probably seen all these massive configuration files that are written for, that you have to kind of understand which every line is. No need for that. It's optional if you want to configure anything, but no need for it. You can customize the number of cores, memory, and disk per instance. And by customizing that, I mean you can have, let's say you have a workload that's very CPU intensive. Let's say it processes video. But it maybe doesn't need that much memory. So you can go and have a 32 or 16 core instance with a very small amount of memory, and exactly to the number that you want. So they're customizable to the number of cores and to the exact megabyte of the memory. And same goes for disk. So that really gets you a lot of saving. You don't need to buy these massive instances and be wasteful of memory and disk or cores. Everything's load balanced and auto-scaled, from ground up. And A/B testing, which we're going to show. Container and microservices is ready natively. And we'll show that in a second. And the vendor flexibility is there. And I'll show that it's not Google specific, actually, to other cloud providers as well. So without further ado, Patrick, why don't you go through all this and give us a demo?
OK, let's get started. I was happy to see a lot of you are IntellIJ users. This is going to be especially relevant for you. We're using IntellIJ for the demos today. My team builds a number of plugins into both Eclipse, IntellIJ, and Maven and Gradle, and we target all kinds of Google Cloud Platform services. We're going to focus on App Engine today and the Google Cloud Debugger. So the first thing that you'll see here is that we're actually, sorry to ask so many questions, but show of hands, how many of you use the Spring Framework? Yeah, that's what I thought. You'd have to be hiding in a cave for the last 10 years or 15 years not to know about the Spring Framework. It's really important for us that it's really easy to take a typical Spring Boot application, deploy it to GCP, and things will just work as you expect, or even better than you expect. So what you see here is basically a at-rest controller. I just downloaded the Spring Boot demo from GitHub and modified it to add some endpoints for this demo. It's really just plain vanilla Spring Boot. So what we can do is we have all of our tools features bundled together in this submenu over here, and also in the natural entry points where they should be in the IDE. We have Google Cloud Source Repository integration, which lets you check in and import into the free Google Cloud Source repositories we offer in your project. We have Cloud, aka Stackdriver Debugger integration, which we'll talk about later. And we also have App Engine support so you can run your local dev app server for App Engine Standard. You can deploy both to App Engine Standard and App Engine Flex. For local run for Flex, obviously, it's sort of your own environment, so we let you figure that out for yourself. Okay,
Patrick, can you describe how do we get this plugin to appear on IntellIJ?
Oh yeah, sure. Most of you will probably know, as your IntellIJ users, that JetBrains has a plugin repository that you can access through preferences or settings in another operating system. You just go to Browse Repositories, search for Google Cloud, and you'll see our tool right there. Install, restart, and you're good to go. So what I'm going to do first is I'm going to take our application and deploy it to App Engine Flex. So this is our deploy UI. The first, probably most important thing that you need to decide when you're deploying to App Engine Flex is what are you deploying to App Engine Flex. There's a peculiarity about IntellIJ. This is Ultimate Edition, by the way, where if you're building a web project, it'll automatically create a web artifact for you that people often use for deployment. But it does not do that for jar-based projects, which typical Spring Boot projects are. What we've done is we actually inspect your Maven model and figure out what your primary target is and allow you to deploy that. So what you see here is the option of basically selecting that Maven build for this project, which is called Spring Boot Simple. You can also just pick a file system jar or war anywhere in your file system, and we'll package that and deploy it for you. The next thing you need to do is pick which GCP project you want to deploy your App Engine project to. So it's a real pain in the butt.
Yes.
Sorry, Amir. To actually have to configure authentication for tools typically, right? You have to either create a service account or application default credentials on your cloud provider and put that in a key file somewhere. We take all that pain away by having this login widget, which if I hit add account, we'll take you through a web flow for authentication and store the credentials locally, so your session is just there for as long as you want it to be. I'm going to cancel this because I've done this already. So we have this user. This is my personal account, by the way. And I'm going to pick the project I want to deploy to. Because this project has already been enabled for App Engine, you can see which region it's deploying to. And then we see that the environment is App Engine flexible because we also support App Engine Standard. If your app had App Engine Web XML, then you would see App Engine Standard here. And finally, we have the version field, which I'm going to overwrite in this case to 5.8, which I think is a version of the code that I've got checked out.
So Patrick, just to so this is, I have a version already installed. I can just basically over here version up right from the IDE and deploy the next version. And it's going forward. So my, let's say, current production is 5.7, something like that, perhaps?
Sure, absolutely. We're going to talk a little bit more about versioning and the App Engine model for services and versions in a second. So I'm going to kick off this deployment. So what we'll do is we'll make sure that your Maven artifact has been built, which takes just obviously a few seconds, hopefully. And then we actually package source context into it, which we'll also talk about when we show you the Cloud Debugger, and start the deployment process.
Patrick, so in the background, what I'm over in here, it says building and pushing image for this service or this microservice, and this is a container-based sort of deployment. But you really didn't have to deal with Docker push, image hub, like all that stuff.
That's
You just
right.
went from
Yeah.
code to containers. How did that happen?
The sort of vision for App Engine Flexible is to have standard infrastructure for running containers. But what they want to do is make it as easy as possible for people to use the platform without knowing anything about containers. So if you don't want to customize your image with some native dependency, you don't have to. You don't need to have a Docker file or even app YAML. And you don't even need to have Docker installed locally because we have a cloud build service which will orchestrate into the deployment so that we can produce the right Docker artifact for you.
I see.
So that's what's happening right now. We're actually streaming the results of the cloud build for the Docker build back into the console. But it's actually all happening on the cloud at the moment.
So you built a container, you pushed it to a repository, the Google Container Repository, and you made it go live, and you hooked up all the networking and all of that. Okay.
Yeah, so because this is not App Engine standard, and because it's sort of built on the basic building blocks of virtual machines, you the products that you're most familiar with at the base of the pyramid we looked at earlier.
Right.
The cost of spinning everything up is a little larger than for App Engine standard, which uses shared resources for deployments.
Correct.
Okay. So it's updating the service here. I'm going to go over to the Cloud Console and show you the App Engine console. This is actually a deployment some deployments that I did earlier, just so that we didn't have to wait too long for the new version to be serving. What you can see here is that we've got version 5.8 serving, and version 5.7 serving, version 5.6 serving. The traffic allocation is 100% on 5.7. This is basically your version that all your users are currently seeing. We've done a deployment to 5.8 that nobody is currently seeing. So App Engine provides a model that helps you with a microservices architecture through our services so that you can basically label your deployments with a specific service. And if you go into your services list over here, you'll see all your services and versions.
So you have one service right
Right.
now and one version. What I usually do is I don't like to send all the traffic to the new because things may be breaking. Can we do 5% of traffic maybe?
Yeah, absolutely. When I worked in the olden days on Java backends, trying to set up either experimentation features or A/B testing or just release verification was so difficult we didn't even bother, right?
Right.
We would just deploy and roll out, and if there was a bug, roll back, right? But now with App Engine Flex and App Engine Standard, it's really easy to just change the traffic mix so that a really small proportion of your users start seeing the new code. So we're going to save that. And in a matter of seconds, the App Engine front ends will start sending some of your traffic to your new version. Let's see.
You refresh the page.
There you go.
All right.
So you have 9% of your traffic served by this new version.
Okay. And Patrick, let's say this is broken. Can we roll back, please?
Yeah, sure, I'll roll back. So we select that. Select over here, migrate the traffic back. I should also show you, this is just a silly Hello World app, but this is v5.7. Now, let's say we've verified that 5.8 is good,
Sure.
and we want to send 100% of traffic to it. We can do that. Migrate the traffic.
Should be a couple of seconds.
Yeah, it shouldn't take more than just a few moments. There we go.
Okay.
100% of our traffic is now being served by the new version. If I go back here, I see that 5.8 is a version being served to my end users.
Awesome. All right. So, Patrick, let's say 5.8 was a really successful release.
Yeah,
and
exactly.
it's getting really, really famous, and people are just coming right to your app. What do I do?
That's a good question. There's another thing that when you were faced with this issue in the past, it was a real headache. You don't have enough capacity. Either you're a consumer app that's been more successful than you had hoped for, right?
Right.
Or you're getting really spiky traffic where you need a lot of resources at a certain time of day, but not the rest of the day. What you really wish you could have is not worry about capacity and have capacity managed for you. And App Engine actually does that. So what we'll do is we'll show you that we've got the versions. Let's go to the instances and take a quick look over here. We see that there are currently 2 instances running for, yeah, that's version 5.8. Good. Fresh. So by default, without any configuration, we'll run 2 instances just for backup. If there's an issue, you still can serve traffic. But what we'll do now is, let me just actually show you real quick. You saw it earlier. There's an endpoint on this web app that is very slow and very computationally expensive. So what we're going to do, sometimes it comes back really quick, and sometimes it comes back really slow because it's just calculating digests of numbers and looking for one that starts with 007 on a loop. So it really taxes the CPU. So what I'm going to do now is I'm going to use Apache Bench to simulate 10,000 requests, 20 requests at a time. I'm going to go ahead and start that.
See, so I guess Patrick, like, what I saw here, you didn't do any configurations around capacity provisioning. I didn't see anywhere you telling us, this could or could not happen, or what sort of version this is. So how does the backend know that this is gonna,
That's
be
a
an
good
issue?
question. I think by default, the CPU load is what the autoscaler is going to use as its signal for spinning up extra instances. But you have a lot of control over that. If you specify your own app YAML, you can do it based off of request
Memory.
PPS, all kinds of things.
Okay, that's awesome.
So let's go back and take a look at our instances really quick. So you can see now that App Engine has already started spinning up a new instance.
Sorry, I'm going to make a note. It says no request at this time. It's because it takes a minute or 2 for the request to propagate into the dashboard.
Yeah, there's a little lag on the summary.
This is a new demo, but yeah, so you can see the bottom, the VM is starting up. Maybe do another refresh.
Yeah, so now this is really taxing the system, and to make sure that we keep on serving traffic in a reasonable latencies where the system is continuing to spin up instances, and at some point is going to find that it's handling the traffic well enough, and it's going to stop.
All load balance. Can you do another refresh? So I think in the last, we spun up from 2 to 6 to 7, and 3 more coming up. Okay.
We've got, let's see, 7 of them are already serving, right? So these instances get spun up and work a lot faster than, for instance, a deployment. It's not like you're going to have to wait many minutes before you're serving the new traffic with these instances.
Right. Write that script and get it back set up.
So it gives you a lot of agility.
Right.
And when the traffic stops, App Engine will scale down so that you're not spending more than you need to.
Just for my pleasure, can you do another refresh?
Sure.
Let's see where we're at. Let's go all the way down. All right, I think it found. All right, so it auto scaled up.
That's like 10 instances going.
Okay.
All right, I think that was it for this part of the demo. Should we go back to slides?
Yeah, slides, please. Okay, cool. So let me just take a second to describe what we did right now. Right, we started off with a plain application. We containerized it without really having to interact with Docker. We employed a microservices architecture in the background. We have a repository that has our container in it for future reference. The container went online and went healthy with 2 instances. We did a A/B test to see if the service is actually, or the version of the service is actually what we want. We verified that it was. Then we migrated everything over. Then we loaded the microservice, and it scaled up. I mean, think about how much time it would take for you to go through this cycle if you would want to do this through the traditional way of handling an end-to-end infrastructure for application development. This took about 9 minutes, I think, on my clock over here. So this is pretty good, and it's a lot of addition to productivity for our developers. So developer time is now free to work on what's critical, and that's your business, not on the other stuff. And so if we move back to what I showed you guys, and we were up here, right? Now the question may be, okay, this is a lot of good magic, I really like it, but I really want more control. I want to actually have my containers set up in different regions. I want to have these containers to have certain level of redundancy. You just really want to have all the control. All right, cool. And sure, you made the App Engine decision first when you were getting in, but now you can just drop down to the container level using our Google Container Engine, which is based on Kubernetes. And there are a lot of talks about Kubernetes, and you guys should definitely, I would recommend go and check it out. But Kubernetes is a container orchestration system. And we have a hosted version of Kubernetes, which is called Google Container Engine. And what we're going to show you guys here is we're going to get this migration happening, going from App Engine to Container Engine. So we're going to show that. And then we're going to now work with the live debugging issue that we talked about and see what happens if this application is actually having a bug that we can't replicate locally. And logging as well, which is a big problem. So Patrick, let's drop down one level on the application, on the infrastructure layer, and get some debugging and logging going. Back to the demo, please. Thank you.
Okay, this was a fun little project. Basically, figure out how do we replicate the experience we just showed you on App Engine on Kubernetes with the same service integration that App Engine offers. For instance, the Cloud Debugger and Google Cloud Logging and Google Trace. All those products should just magically work. With GKE, you have your own configuration. You're sort of responsible for making everything work. But it turned out most of this is really easy to do. This is the reason basically I selected the OpenJDK 8 from Docker Hub as my base image, which is not the image I would normally recommend. I would recommend using our own Google curated images, which do a lot of extra work to make sure the configurations are right, and they're updated for security patches on a weekly basis. But I just wanted to show that with a plain vanilla image,
right, and I think that's a good example
and minimal configuration, you can actually deploy the same app onto Kubernetes and have integration into the rest of our services.
Yeah, Patrick, I was going to say, this is a good example of, you can just go to a different runtime if you want. There's nothing holding you back. So, all right.
Yeah. So if you see here, what all we're doing is using the base image, exposing 8080, downloading the Cloud Debugger agent, which is open source on GitHub, by the way, and configuring it as in the agent path of the Java invocation. So this is what a typical Spring Boot Docker image would have: Java, and then the app. But there's an extra step that we have to do because we're going to be talking about the Cloud Debugger later. But one thing that App Engine offers that the raw infrastructure environment does not is a service inversion model, so that you can identify a large set of instances as providing the same job, right? Providing the same binary, doing the same thing. We need to do that for our diagnostics integration. So what I've done here is used Maven filtering to actually filter the service name and project version properties from the project into the Docker file. Okay, and let me just quickly show you the POM XML as well. For those of you, you guys are gonna get tired of this, but how many of you are using Maven regularly? Yeah, Gradle, out of curiosity? Okay, that's more or less what I expected. So
it's like 70-30?
70-30, something like that. So we have Gradle and Maven plugins, so everybody's covered. In Maven, there are various ways that you can build Docker images from a Java app. So we showed you earlier that with App Engine Flex, you don't actually need to worry about that part. But if you're deploying to Kubernetes, we're no longer taking care of the Docker build for you. You need to create the image. The way that I've done that is I just took the Spotify Docker Maven plugin. They have two of them. They both work differently. I just picked this one for the purposes of this demo. And the image name is actually really important because the Google Cloud Platform offers a Docker image container registry called the Google Container Registry.
It's a good name.
GCR.io. You want to name your image after GCR.io/your project, and then your artifact name and any tags you want to add to it. So we do that here. And then once you've built your Docker image, all you need to do is push it to container registry, which is as easy as calling, you should see here, gcloud docker push which is the name of your image. Oops. Oh, I've got two layers of zooming going on right now. All right. So I can show you this. What I've actually done here, it's kind of neat. I've bound execing the Docker, the gcloud Docker push to the deploy phase of my Maven project. Because if you think about it, the Maven life cycles, deploy is about publishing your artifacts. And your artifact, when your Docker base is no longer a Java artifact, it's a Docker image. So if I kick that off, what will happen is we'll build the application, filter the Docker file, create a staging directory, and Docker build that, and then push that to Google Container Registry.
So Patrick, I could have, if I have another container that I've built previously on another platform or another place, I could just point to that and deploy that on Kubernetes and GKE, right?
Yeah, with containers, there's a whole lot of stuff that you could do.
Right.
One thing that we didn't mention earlier is that App Engine Flex also uses Google Container Registry. So I'm going to take you over there, and you can take a look. This is the Google Cloud Console and the Container Registry page. You can actually see all of our App Engine builds show up in here. So we can see the previous deployments that we did right there. These images are deployable to Kubernetes.
Right.
Now, if you take a look at demo app, which is the image that we just pushed, we have v5.8, which is the image that is actually the image 22 minutes ago. I pushed an earlier example, so this is the one that you were seeing. I didn't make any modifications, so. All right. So this service is actually running on Kubernetes at the moment. If we go to the container engine page and look at our cluster, I created this cluster earlier. Similar to App Engine Flex, it's built on VMs, so it takes some time to start. Not too long, just a few minutes. We then created a Kubernetes deployment on that cluster that has 3 pods. And I initially pre-configured it to be serving the 5.7 version of our app. I can go over here, just reload it, and you can see that this is v5.7. So what we'll do is deploy version 5.8, which we just pushed to GCR. That's a relatively easy thing to do in Kubernetes. You can just go and edit your spec. Oops. So let me just zoom in here a little bit. You see the image that's being used by the pod is demo app v5.7. All I need to do is just change it to 5.8, save it, and close. And now my deployment has been edited. So at that point, the Kubernetes master knows that the deployment that it's got doesn't match the spec anymore. It's going to bring down the pods, bring up new pods with the new version, and in a few moments, just as long as it takes for Spring Boot to get started, you'll be able to start serving traffic again. There are a lot of, you can configure Kubernetes to do rolling upgrades as well, so that you have no downtime between swapping versions. So you see here that v5.8 is now running.
So Patrick, you basically did what we did in App Engine, going from 5.7 to 5.8, just with a lot more control. So,
It's a more manual process?
Yep, it's a more managed process, right.
Yeah. Okay. So the next thing that we're going to be showing you is, as I showed you earlier, in the Docker image, we configured the Cloud Debugger agent. The Cloud Debugger agent is a necessary piece of the Stackdriver debugger, or the Google Cloud Debugger, which is a really exciting product that Google provides. Amir,
yes.
Earlier, sorry about that, Amir. Amir earlier on asked you guys how many of you had actually had a hard to debug production issue. It's happened to me a few times, and it happens especially at scale. Right? When you have a large cluster under a lot of load, a lot of bugs can pop up, corner cases, that you simply don't have the logging in place to effectively diagnose. And you don't have a lot of options for debugging because you can't attach a debugger in production for a couple of reasons. You don't want to actually block requests coming into an instance. And if you have 100,000 nodes, you don't know where that bug is going to happen. You can't connect to all of them. So the Cloud Debugger is a piece of technology that Google developed internally for our purposes, which solves this problem. The way that it works is that when you set a breakpoint in the Cloud Debugger, there's a Cloud Debugger master that monitors all the agents running for a specific service and notifies them that they need to be looking for this particular breakpoint. The second any traffic on any of the instances actually hit that line, they'll notify the master, and eventually you'll be notified as well. They won't break execution, they'll just capture state in the stack frame and store it in a database.
So basically, I don't have to worry about having downtimes and maintenance windows and all that sort of stuff anymore. Okay.
That's right. So let's actually go and show what kind of bug we want. Oops, we want to diagnose. Let's go back. Oh, that was it. Here you go. Something's not right. I don't know if you guys can figure out what it is, but the site is telling me that my browser is Firefox, which is a great browser, by the way. But the browser that I'm using is Google Chrome.
Looks like Chrome to me, yeah.
That's a bug.
That is a bug.
So let's use the Cloud Debugger to figure out what's going on. This is happening on our Kubernetes cluster. You can start the Cloud Debugger just by finding it over here.
Before you go there, Patrick, can you show the code that's actually making this happen? Maybe we can just eyeball it. All right, if user agent is Mozilla.
Yeah, we're basically serving the hello path.
It looks
We're getting the user agent, checking its contents for a specific string. If we see it, we figure out what browser type it is, and it looks like it makes sense, right? Mozilla is Firefox, Explorer is Explorer, Chrome is Chrome.
Cool.
So I have a Google Cloud Debug Run configuration. Since you're IntellIJ users, you're all familiar with the way that debugging works in IntellIJ. You have the run configuration, and you click the debug button. So this is the Kubernetes version that I had. I'm going to attach to it. I have an old watch point from earlier on. I'm going to delete it. Oh, hold on a second. Let's try that again.
Okay, so you're going to...
I was practicing this earlier, and I had some previous state.
No, I was going to say, so you're just going to listen in line 52 where Firefox is displayed to see what's happening.
We know that we're seeing Firefox, which means that that line of code is being executed. Let's find out what's going on. We're going to set the snapshot. When the check mark appears, that means that the master has confirmation that that's a valid line. We're going to go and trigger the bug. We don't know where the load balancer sent that request. It went to any of the 3 nodes that we've got configured. And if we go over here, we can see the state. So if you look at the user agent, let me open that. Guess what? The user agent of Chrome reports itself as Mozilla. This is something that browsers do because of legacy, right? But with the Cloud Debugger, it was really easy to figure out what was going on.
So you basically got a whole stack trace whenever that part of the code was touched, and it's really good for.
Yeah, I want to just point out that the Cloud Debugger is very safe. It doesn't slow down the execution, or if it's a really trivial amount. We use it at Google in production. It only captures the first snapshot, and then it disables itself. So you'll get one sample of what you were looking for. In the future, we're probably going to provide you with more options, but for now, it's just one.
But Patrick, this is really cool, but sometimes I don't know when the trigger happens because it could be an edge case. Do I just wait there? Can you show us a better way?
I can. So let's stop listening and Imagine a real scenario where this is happening, where this sort of hard to reproduce bug suddenly gets reported. Most of the time, you're not just waiting in the version of code that's executing in production. You're doing some feature development. You've moved over to version 9, and you've added some random out, more hellos. I'm really creative here. And then somebody comes and tells you, hey, guess what? We're having this crazy bug in production. We have no idea what's going on.
And that's for version 5.8, by the way, so you've moved on from that.
Right. So we actually capture source context at build time and deploy it with the application, both in App Engine, and we configured things such that we do it for Kubernetes as well. Which means that when you connect, we've actually identified that the version of your code, let me zoom in here, is not the same as a version that's running in production. And whether you've committed things or not, or you have unstaged changes, we'll take all your changes, stash them, and put you on the version of the code that makes sense for the service that you're debugging. So let's do that. I'm going to get rid of this guy because, like I said earlier, it got caught already. And we're going to create, oops, I didn't mean to go there. Create the new breakpoint. But at this point, this bug is always going to happen with Chrome browser. But for a bug that happens once every blue moon, due to some race condition or whatever, you're certainly not going to stop here and leave your IDE in this state waiting for it to happen. So what you can do is you can stop, and instead of telling the debugger to stop listening, you can tell it to continue. At that point, we know that you want to go back to your old workflow. We offer to check out the branch that you were on and unstash your changes. So we'll go ahead and do that. And if we go here, we see that we're back to version 5.9. So now if this gets triggered, when we come back here, we notify you in the IDE that your hard-to-reproduce bug has happened, and you can continue your debug session. And if you look at the version of the code now, it's back to v5.8. I mean, many times I have been tearing my hair out because I've attached my debugger to a version of code that is different from the one that my editor is showing me. It happens all the time, and you can really, it can take forever to figure out what's going on, especially if you have lines that kind of match, right? In terms of they are executing, but they're not the lines that you thought.
Right.
Okay.
That's cool. So, Patrick, this is all great. Another one of the scenarios that I can think of is I've deployed my version 5.8 as you're showing over here, but I forgot that I would like to log a certain value or a certain field over time. I've moved on many, many versions, and it's going to be quite the hassle for me to go back and deploy a new version, do the change code. Maybe you can show us a way that we can do this better?
I'd be happy to. This is the scenario I like to call, oops, I forgot to write logging statements in my application. This is a scenario that helps with bugs. It also is a scenario that helps with people who might be using logging to generate metrics about their application. Maybe piping their cloud logs into big data, right? Into BigQuery, for instance.
Right.
So in this scenario, we're actually using the same cloud debugger agent to insert dynamically log statements into your production app without requiring you to redeploy. And now every time that line gets executed on anywhere in your cluster, you're going to see it in your logs. So we don't have integration into the IDEs for this feature yet, but we're working on it. You can use the Cloud SDK gcloud command to create these log points. If you take a look over here, let me zoom in.
Patrick, can you show the line item in the code that you're trying to log?
Yeah, that's an excellent idea. OK. So let's see, line 37. I forgot to mention that we have some really nice handcrafted Java libraries that are coming out in beta at the moment for some of our main Google Cloud services like Data Store. And I'm using that here. You just import it in your POM XML, and you can write to Data Store. Data Store is a really good idea for people who expect to have really large data, right? App Engine Flex can help you scale your computation, but it can't help you scale your database. You need to use a scalable database if you really expect large scale. And data store is a database that scales horizontally automatically for you. It's sort of like the app engine for databases. So we have the system out print line here, but really what I wanted to do is figure out every time I saved a data store, I want to be notified that that save has occurred. So at line 37, you see that we're actually just returning the greeting. Let me hit the endpoint. I can show it to you. Right, we're just generating a timestamp, saving it to the database, reading it, showing it to you. This is for demo purposes only, not particularly useful. Now, if we go to cloud logging, so cloud logging is a service not tied to App Engine that aggregates all your logs for all your instances, because copying logs from individual instances is a real pain.
Yep.
So what we've done is we've filtered by next demo, which is a tag that I'm putting in front of the login statement so that we don't get all the noise from all the instances at the same time, all the non-related to this login statement. And what I'm going to do is so if I refresh here, oops, let's go. If I refresh this and go back to logging, you see nothing is being outputted.
Right, because you never wrote anything there to
Right, we don't have a logging statement.
logging statement, right?
So now, if you take a look at this gcloud command, can you guys see that?
I think it's fine.
All right. So what we're doing is we're calling the debug subcommand to create a logging statement in the demo controller.java at line 37. The demo controller doesn't have to be fully qualified if there's no ambiguity. If there is, fully qualify the class. We've added the next demo, we've prepended next demo to the statement and just actually used a value from the context where the logging statement is in the string and specified the target, which in this case is demo app 5.8 running on the Kubernetes cluster.
Patrick, I'm just curious. Oh, okay, cool.
Yeah.
I was going to say,
Go ahead.
were we on 5.8 or 5.9 version on the?
I believe we're on 5.8.
Okay, we were? Okay.
Yeah.
Just curious.
I can double check for you. There you go.
Oh, 5.8. Okay. Excellent. Sorry.
So if we go back to visit, and hopefully the demo gods will be kind to us.
It should appear here any second.
Come on.
Come on.
Come on.
Going through all the
I've got a bad feeling about this.
You do?
Things have been going too well.
I have a feeling you're.
Oh!
It appear. Yes.
There it is.
All right.
Fantastic. This works at scale. There are people with hundreds of thousands of App Engine instances using cloud logging and our diagnostic services.
Yeah, I imagine, because you may even have code that's deployed way before, right? And you just don't want to go and mess up some running application, and you want to be able to just.
No, really, what these features are about is saving developer time.
Yes.
Making you more productive, making the time to identifying a bug to fixing a bug as short as possible.
Yep. Again, core business, spend time on core business code rather than all these other stuff.
All right, that's it for the demo. We can switch back to the presentation.
That's really great. We've got about 10 minutes. I'm going to just do some concluding slides. So we saw what happened, right? We went from App Engine to Container Engine. And then we did some live coding, live debugging, and also live logging without having any downtime incurred on our application. And so as Patrick talked about, I just wanted to say all these tools are open source. They're all available on GitHub, and I'm going to give you guys the link right towards the end of the talk when this ends. But we've got Eclipse and IntellIJ support, Maven and Gradle. There's a bit of difference between the IntellIJ and Eclipse support, but we're working on that. These tools are continuously getting updated. as time passes by, so you're going to get the updates, but available. And you guys are going to be going through the different sessions and seeing many different services that we offer, everything from ML and Bigtable and BigQuery and Spanner and so forth. All of these have handwritten Java libraries available to you guys to use, so you don't have to do a lot of boilerplate code around authentication and so forth. So please go ahead and use these. I will give you guys a link to this as well towards the end. And I'm just going to talk a minute about vendor flexibility. And because of what we did, that under the hood for both App Engine Flexible and also for GKE, this was a container-based solution. You really can take this anywhere. And by anywhere, we mean truly even outside of Google, right? So yes, you can go with Container Engine and Compute, because those will do the job. But you can also run Kubernetes on a hybrid mode where you can have machines in on-premise and machines in cloud, and Kubernetes could move the containers between the two infrastructures. You can also go to the other cloud providers, and there are a few out there, and you can just run it on your local machine as well, basically anywhere the Docker runs. So you're free to move to other platforms. And that concludes our talk. This should be from top to bottom the links you would need. The top link would be your gateway to everything Java and Google Cloud. The next one is where you can find all the handwritten libraries, and then the 4 GitHub repos that have the plugins in them. We always welcome issues, bugs, requests, feature requests, comments.
Absolutely. Please go to those GitHub repos and check them out. If you want to contribute, we would love it. If you have ideas, we would love to hear them.